All right, welcome back to some more Black Hat Python. In this one, we will be writing an ARP poisoner using Scapy. Now, if you're not familiar with ARP poisoning, I can make a separate video on that. Let me know in the comment section down below. But to give you the basic rundown of it, is it's basically a man-in-the-middle attack. You'll use this when you're on a network, on the same network as the victim, and you can basically spoof the router essentially into thinking that you are the victim and spoof the victim to think that you are the router. So you can basically sit in between and proxy his packets, and you can do things like, I don't know, dropping his packets for denial of service, which is one of the first attacks I've ever done as a hacker way back in the day, though I used some pre-built tools for it. Obviously, I didn't write my own in Scapy or anything crazy like that. But yeah, there's so many, and you can also snoop in on packets and things like that. There's all kinds of things you can do with this attack, but in this case here, all we're going to be doing is actually spoofing by poisoning the ARP tables. Now, that ARP stands for Address Resolution Protocol, and basically it's a table of MAC addresses. So for this, we're going to be importing process from the multiprocessing Python module, and from scapy.all, we're going to be importing a number of things: ARP, ether, conf, get, if, HW adder, send, sniff, SNDR, SN receive, SRP, and WRP cap. If that sounds like a lot, don't worry. There's a lot of code in here. It can seem very daunting. This is probably the most ambitious thing we've built yet. There's a lot of code here. I'm not going to lie to you guys, but I'm going to break this down in as simple a way as I can, and let me know in the comments if there's any questions afterwards. So let's get right into it. The first thing we're going to do is we will be, and of course we're going to import these three things as well, OS, sys, and time. But the first thing we're going to do is create a function called getMAC, and this is going to get the MAC address, obviously, as the name implies. We're going to be passing in target IP, so it's going to take in an IP address, and we're defining this packet variable here. And this might look a little crazy, but I'm going to break down any of the crazy things here. I'm going to break down by showing you the documentation, because I know there was questions about that in previous videos. People saw things and they're like, well, you know, this isn't explained here or there. So I'm going to try to explain it as best I can. So basically this packet variable is going to be running this built-in ether. Remember, we imported ether from scapy.all. So this is a Scapy thing here. So we can look at the Scapy documentation to see how this works. But basically, we create destination MAC address here, which is going to be the default gateway. When I was saying router earlier, another term for what I'm talking about is the default gateway, right? So default gateway here, MAC address, and then it'll be running this ARP function, passing in the parameter OP who has, which we'll go into what these are here in a little bit as well. This corresponds to the actual ARP protocol, the address resolution protocol, and PDST as well, the target IP. So what we can do is we can pull up the documentation. We can look at what this /ARP thing is, what this ARP thing is, right? So we can see here, if you want to do some classic ARP cache poisoning, this is, by the way, this is the Scapy docs here. You can see that you just would do it like this. Basically, we're doing with the ether and the /ARP OP who has, that's the operation we're going to run, the who has operation, and taking in the source and destination. So if we go back to our code, we can see that that's what we're doing. Then once we do that, we assign whatever we get back into this packet variable, right? So now we can do this here, response, and then this throwaway variable, and then we're going to say, here's another built-in Scapy thing, SRP, packet, timeout, retry, verbose equals false. So we want to retry about 10 times, and we don't want a verbose output because we want to have our own output, which we'll get to in a bit. And we'll set a timeout for this, right? So if we were confused on, okay, what is this SRP thing doing? Well, once again, we can go back to the documentation. And if we do that, we see a number of things here. So we see the function SRP basically does the same but for layer 2 packets. So, well, okay, the SR function is for sending packets and receiving answers, okay? The function returns a couple of packets and answers and unanswered packets, right? So it's saying essentially this SRP function here will do the same thing as SR, but on layer 2. So that's what we're dealing with here. We're dealing with layer 2. So we're going to want to use SRP. So we can also look at down here, right? Send and receive packets at layer 2. And here's a little example of how you'd use it. So instead of answered and unanswered, we have RESP and underscore, because we don't really care about the unanswered. So that's why we can just denote it with an underscore. It's a throwaway variable that we don't really care about. We care about the ones that have a response. And this is, effectively all this in here. All this here we already have as the packet variable. So imagine all this stuff that I just highlighted is the packet variable. We just pass that into SRP, and we can give it some other parameters as we actually do here. You see we gave it some additional parameters, which were timeout, retry, and verbose. And so the answered packets will be in RESP, right? So we want to iterate through RESP. The first thing we don't care about, the second thing we do. So we're going to return just that, R ether, so dot source. So this is going to give us the dot source attribute for all of this. So if you were confused on what that looks like, you could do some debugging, things like just printing out everything in here first to seeing what that looks like. There are probably objects, and we're just grabbing the source attribute from each one. And the next thing we're going to do is define a class called Arper. So we'll have an initialization function, and you always have to initialize with self. But as you'll see down below, we're going to pass in some things from the command line. So we're going to pass in a victim, gateway, interface. We'll give the interface a default value in case it's not passed in. It'll be ETH0 in my case. And now we're just going to assign those. So self.victim, victim, get MAC, all this stuff, right? So we're gonna be concerned with the victim's MAC address, the gateway's MAC address, the interface, and then this comp.iface, comp.verb. That's also things that are special to Scapy. So that's why we're gonna be using it. I believe I could find that here. Comp.iface. Yeah, you see here. You see that, a mentioning of that. In up here, yeah, you need it for sniffing and things like that, right? So there you go. You can always look through the documentation, and even if the documentation fails, you can always Google for this stuff to find some more good information. I'll show you an example of that here in a second. The next thing that we're going to want to do is print off some stuff for our own sake, so that when we're running this, we can see what's happening. So after we initialize all this stuff, we're just going to print that, hey, we initialized on this interface, whatever interface, right? And when we find the gateway, right, like when we assign the gateway and the victim, we're going to print off where that's at, what the actual MAC addresses are and things like that, right? And we'll print 30 dashes just to keep our output nice and clean so we don't get confused what corresponds to what. And now the next part is the really important part of this Arper class, which is this run function here, or this run, I guess, method is what you would call it. What it's doing is it's creating multi-threaded processes for poisoning and sniffing, right? And if you were confused, if you looked at this and you're confused, well, where does this process thing come from? We didn't define process, or, what is this thread.start and all this? If you're confused about that, just scroll to the top. You see from multiprocessing, import process. Well, that's where it's coming from. So we can just look that up if we are confused on how to create this or what this is doing. So you can go straight to the Python documentations for the multiprocessing library. And you can see that it has a class called process, which is what we explicitly imported for, at the top of the code, right? And we can then see how to use this, right? In multiprocessing, processes are spawned by creating a process object and then calling its start method. So that's basically what we're doing. And we can scroll down here to see the uses here. Process, give it a target. You can also give it some arguments. And yeah, there's thing of documentation here on this stuff. So you could always refer to that. So our target will be poison, right? Self.poison. And then we'll just go ahead and start that thread. So the next thing here is we'll do the same thing for the sniffer, because there's two components to this. There's going to be the poisoning aspect and the sniffing aspect. So as far as poisoning goes, we will define that here. And it won't really take in any parameters other than self, which everything has to take self as a parameter. And the first thing we're going to do is we're going to poison, we're going to set the poison victim variable as this ARP class, I believe. This is another built-in thing, built into Scapy. And what we're going to do is we're going to set the values of its attributes. So all of these here, OP, P source, P destination, HW destination, hardware destination. These are all built-in attributes of this ARP class. I hope I'm saying these terms right. I'm not a programmer, but I believe these are called attributes, and this is the class here. These are basically what I'm saying. These are built into the ARP class. So, but we can set the values of them right here as we initialize this function, and that's what we're doing. And once again, if you're confused on what these are doing, a lot of these here, they come from the actual address resolution protocol. They actually come from ARP. So if I look at the Wikipedia page for ARP, for address resolution protocol, I can see all these things. So for example, say I didn't know what op was. Well, it probably corresponds to this operation right here. And you see in the actual ARP packet, it's located here. And it says specifies operation, the operation that the sender is performing. So it can either have 1 for request or 2 for reply. In this case, we are dealing with the reply, so that is why we're hard coding this to 2. So there you go. If you were confused about that, and similarly, you could look up what P source is, P dest, hardware dest. But basically, hardware dest will be like the MAC address, right? So all this stuff will be like the IPs, the P source and the P destination. So P source will be like the source IP, and P destination will be the destination IP, whereas anything with HW in front of it will correspond to a MAC address. So this is the MAC address of the destination. And I mean, if it was any confusion to you here where you see the print statements, we're printing that off. So we're initializing all this, right? But then another thing we're doing is we're printing off a bunch of data here as well, just so we know what's happening in our code, that we're at this point in the code. So we're going to see that, hey, the IP source is going to be P source, like I said, and the hardware will be the MAC address, right? And then you can also call this summary, I believe, method or function or whatever. I think it's method on Poison Gateway. So another built-in thing there you can do for help you with the output, as we'll see, because we're gonna demo running this script to see how it, what it actually looks like when it's running. But yep, we can always Control C out of it to stop, as we see here, the keyboard interrupt. And so, but basically here in the while true, this is where the thing's actually running. We're gonna keep writing period symbols to to the actual console, as we'll see, and we'll do a standard out.flush. And now we're going to be trying to send the poison.victim. And now the send thing here, once again, it is part of Scapy. If I go here, you can see when we were doing the classic ARP cache poisoning in this example, right? All this was encased inside this send. So we got to make sure that we actually send this stuff, because we have all of this stuff here. We've done all this. Now we just need to send it. So that's why this is where we're actually going to implement that. So we'll do it in this try block here. We're going to try to send poison victim and poison gateway, right? Now these were initialized up here, and we set the attributes. We initialize the attributes up here, remember? So we have everything set up as we want it for these. Now all we need to do is call send on them. So we're going to try that. And the exception will be if we keyboard interrupt. We're going to restore all of the things that we poisoned back to what they were before. And we'll see what that function is doing here in a second. And then this might be interesting to you if you're a little bit new to Python. You can actually have an else clause inside right at, as a part of a try except. And the way this operates is that it tries this, right? And if it doesn't hit an exception, it's going to look to see if there's an exception first. And if there's not, if this does go through, then it will go to the else block, which is time.sleep2. So we'll sleep for 2 seconds. And then we'll write another period, check for this stuff, sleep 2 seconds, et cetera, until we eventually hit the exception from a keyboard interrupt. So that's how this is actually going to run. That's the actual flow of it. And of course, for the sniffing function, we will define a count. I'm going to set that equal to 1,000. So basically, I'm going to be sniffing 1,000 packets. And I create a BPF filter here, which, like I was saying previously in videos, that this is like what you would filter in on Wireshark if you're trying to filter your packets, or in TCP dump. It'll be in that same format. And so in this case, we want to be filtering for the IP host equal to our victim's IP address. And we'll set a packets variable here once we, calling the sniff, right? The built-in sniff function from Scapy. And with these packets, we're actually able to write them directly into a PCAP file using a really handy built-in part of Scapy, which is this WRP cap, which we imported at the top, if you recall. So I actually did that, and I opened it up, and you see here I opened in Wireshark, and I got all this stuff. We're not going to get into this in this video, the actual PCAP results, but yeah, I have everything's here. But in future videos, I'm actually going to be what they're going to be bringing us towards in this book is going to be processing PCAP files and how we can do really interesting things in Scapy and Python to use them. So we'll be doing that in future videos. Now, from here, basically, we will be printing off we got the packets, and when we're done, it's going to restore the poisoning, pretty much undo all the poisoning, restore things back to how they were, terminate the threads, print finished, all of that stuff, right? Now, what is the restore function actually doing? Because we mentioned that a few times. We didn't see that until now. We're just going to print that we're restoring the ARP tables, and we're going to call send here. This is another way to do it. We could have, when we assigned the values, the attributes up here, we did it, each in their separate line, but we could have done this as a all inline here. And this is what it would look like if we did that, but we're just basically taking everything back to normal, how it was before. And once we do that, really, everything will be restored. And down here is going to be the code that gets run when you first run the script. And it's going to be taking in victim, gateway, and interface from the command line positions 1, 2, and 3. And then it's going to be calling the ARP class here, passing in those values. And, it'll run the init function, obviously. And that's going to be assigned to my ARP. And then we'll just call run on that. And then everything will run as we saw. So hopefully this video was of help breaking down what could have been otherwise a really difficult one. Let me go ahead and demo this before I forget, of course. What I'm going to do is I'm going to come back here. This is, a man-in-the-middle attack, so we got to have a victim machine. That's going to be this one here. So if I run ARP-A, I can see the ARP tables. In this case, it just sees this will be the default gateway that it sees here. And for good measure, I can run it here as well. And perhaps I should have sent some packets or done something first. Let's see here. Maybe I can make maybe I can make a ping request. That's what I should do. So if I look at this here, this is on the same network. So I can make a ping request here, and that should get the ARP. That's one way I can get it, right? there's multiple ways I could get its MAC address, but I'll just send a ping request. And now I see, hey, this is the address of it here. If I look at my IP address here, I can grab it. And I'll do that so he has mine as well, because that'll be a way better way for you to see how this is all working. I know this video is going to be super long. I apologize for that, but if you've stuck with it to this point, kudos to you, definitely. There's a lot to learn from this one. Oops. So we run ARP-A again. Now you see it has my Kali box. And what I want to do is I want to keep running ARP-A every few seconds. So what I'm going to do here is, before I kick off the script here, I'm going to create a one-liner in Bash just to keep checking the ARP table so we can see when it's been poisoned. So I should be able to do a while true in Bash here. So we'll say while true. So it's an infinite loop, and we'll do ARP-A, and we'll sleep for 3 seconds. Done. So we'll try that. So now every 3 seconds, it's going to check the ARP table, as you see here. Another thing I want to add, because this is going to be a little bit confusing. So we'll echo a new line as well. So we'll say echo. So that's how we'll run it, just like that. That way you can see it all on a new line. There we go. So now that it's doing that, I'm going to go ahead and run this this code here. So we do Python 3 arper.py, and we'll need to give it a few values here. Oh yeah, one thing I need to do first is I need to enable IP forwarding. Let me just kill this here for a sec. So we need to enable IP forwarding. So the way we do that, we can just echo 1 into proc. Well, I'll need to do this as the root account, actually. So let me change over there. And all right, so we'll echo 1 into proc sys net IPv4 IP underscore forward. There we go. And now that we did that, we should be able to go ahead and run this. We'll need to run this as root though here. Python 3 arper.py. Now we're going to give it the IP address of, let's see here. If we go back down here, if you're ever confused, you can just look at this here. So what it's expecting is the victim IP, then the gateway, then the interface. So let's grab the victim IP here really quickly. I forgot what that is, so let me copy it from here. So victim IP, and then let me just check for the default gateway here, which is that one. And then the interface for me is ETH0, so I'll just pass that in here. And now I'll run it. So let's hurry up and run our one-liner here so we can keep checking. Now this is what it looks like at first, right? I'll keep, changing back and forth between these things. It's going to show here, this is the IP source, IP destination. I guess we could watch it from here too, because we are printing this stuff off. But yeah, we see it keep adding the period every 2 seconds, sniffing 1,000 packets. And we want to catch, this is kind of hard to catch, actually. We got to see with our eyes that the things become the same. And actually, yeah, they are. See, they're the same here, so we're actually poisoning this right now. Let me go ahead and kill this. And I'll kill this as well. And I'll restore the tables. So if we run ARP-A again, we'll see now that they're restored. And that's the reason we know. See, look, when we were poisoning it here, the MAC address for my Kali box was the same as the MAC address, or I guess I should say it the other way around. The default gateway had the same MAC address as my Kali box because we'd poisoned it. And then, you know, before it was poisoned and when we restored it, you know, it was not our MAC address. It went back to its previous MAC address. So, yeah, by the time I even ran this, it already had been poisoned. That's how quickly this thing worked. But yeah, there you go. If we look here, before we ran the script, we see it was this, and then it restored it back to that value. So yeah, that's how the script works. It's pretty cool stuff. Definitely something that could be expanded on to do denial of service and all kinds of crazy things. Maybe in the future we'll do that. But yeah, that's all I had for this video. Hopefully it was of help to you guys. If you watched to the end, definitely hit the subscribe button, like as well if you haven't already. And I will see you guys in the next video. If you want to watch some more of this Python stuff, catch up on the series, go ahead and check out the videos on screen now. I'll see you guys right over there. Thanks for watching as always.